to normal MySQL tuning when it comes to the queries. And as you know, the query, the schema, that's what gives you the bulk of the performance, right? You can have shitty schema and you get nothing out of it, even if you buy the most expensive hardware on the planet. So I'm just going to run through here a little bit to make sure about the sharding and the partitioning. So by default, each data node will partition the data. So if you have two data nodes, you will basically have the data in a table will be divided up to two partitions. And the data will be hashed on the partitions based on the primary key. In this case, it was UID, FID. So some of the data will go here, and then we mirror across like this. And some of the data will be here, and it will be mirrored across. And sometimes, when you do a query, you can then query, and for some queries, it makes sense to make sure that the query is hitting both nodes when you want to read after. So sometimes you have to, But so for huge queries, if you read up many rows, then you want as many CPUs as possible to work on this query, right? So it can feed you back data more efficiently instead of one CPU that is having to troll through a big result set. And in some cases, you would like to just make sure that you are hitting only one data node, because what you have is, and what is very important in the MySQL cluster is the network. To remember that you have a network between all the processes. And network cost, and you would like typically to avoid network as much as possible. So if you want to, if you're just asking for a subset of data, then you can partition your table, and as I said, by default, it's partitioned by the complete primary key. But you can partition it, so you partition the data according to a particular part of the primary key that you want to have. So in this case, we can simply do a create table, and we can add in the word partition by key UID. And this means that all the information about this particular user will be on one partition. So I don't have to ask many partitions for the data. Right? So I always ask one partition. So then I reduce network latency, network round trips, and have faster queries. So here is just an example then that in the default partitioning, the user, the information is pretty much randomly distributed across across the nodes. But when I use the partition by key, well then I can make sure that all my users with the same key will be on one partition and the other will be on another partition. And you can make sure, and you can understand if you are able to use this technique. And it's basically to check the NDB prune scan count counter, and also this range scan count, and if they are, pruned or not. So then, in this way, you can understand: are my requests hitting all the partitions or only one of them? And by using explain on a query, you can also understand explain partitions, select from a query that you think is running slow. And you will see here, if you see all the partitions here, many, then it's not pruned, it's hitting all. If you see one, it's good. So. very binary, but that's the if you can avoid to use blobs inside your schema, that's a great thing. I recommend that if you can, to change to varchar or var binary instead. Another thing that is that you can tune is what is called an NDB cluster connection pool. So from the MySQL server, it can make the MySQL server can make several connections down to the data nodes. Instead of by default, it makes one connection down to the data nodes, and to each data node. But you can set it to make more connections, and then it will be it can help a little bit if you notice that you're not getting through the performance that you're a bit expecting. So this is a good tuning candidate then, because it's basically a way that the MySQL server can load balance over these kind of internal connections from the MySQL server to the data nodes. And that's usually one of the first tunables that one looks at if there's performance problems. There are some mutexes otherwise that are in the way. Right. This picture was also a little too small, but I was gonna leave the NDB cluster more specifics, and we can talk a little bit about how it compares to Galera. Normally, if you look at it, if you're migrating data, it's so much easier. If you're migrating data from NDB and you want to make it cluster and so on, then Galera is the obvious choice. In the case of NDB, you would need to do quite some forklifting. You have to change the schema to start with from engine equal DB to NDB, right? And so on. And that can be, quite problematic. But otherwise, the products are a little bit different, but they also have kind of many of the same limitations, especially when it comes to large transactions. The big difference between Galera and NDB comes in, the locking when you want to, when you do a transaction commit. We have the pessimistic versus optimistic locking, and I would say that NDB is better handling writes than Galera ever will. Because in Galera you will have the writes going to all Galera nodes, whereas in NDB the writes will go to a particular partition, right? And in Galera you're also more subjective to the best the performance that you get. It's all sort of is basically true for NDB as well, but the round trip time between the nodes, that's very much telling you the performance of your cluster. So the big difference here is that in Galera you have virtual synchronous multi-master application. Do you understand what this means? So you write here, commit, and then goes here, and it might be in a queue and so on. Whereas when you have hit the commit and you got the commit back here, you know that it is applied and it's updated on the node. So I think that's the difference. So